Hey there, what's up guys? So you're watching my channel Abbot Academy. So today we will be covering a very important topic from the chapter Electricity class 10 Science. So in this chapter Electricity, I've already made a video on the various formulas and definitions used in this chapter. You can kindly watch the video through my channel Abbot Academy. And in this lecture, I will be covering the various resistance combinations that are used in the chapter Electricity. There are mainly two: parallel combination and series combination. Extremely simple. In this video, we will derive the parallel combination, how the formula comes, and how the series will also derive the series combination, how the formula comes. And at the end, the question remains: what is better, parallel versus series? Parallel or series? Which one is better? Which one should we prefer? And what arrangement is used in a domestic circuit? So we'll give all the answers to this in this video. So stay tuned, and it's my guarantee that all your basic concepts will be cleared. Let's see. So here I have drawn a series circuit. So there are two resistors. This is the sign of resistor. Resistor are named R1 and R2. A battery and a closed switch. Okay, a simple circuit representing two resistors joined in a series arrangement. So let us derive the formula of an equivalent resistance in series arrangement. So, but first and foremost, a very important detail that you should always remember. Please note it down somewhere because it's extremely important. So it is that in series arrangement the current remains the same. Okay, in series arrangement the current remains the same. So the current which flows through R1 would be the same that the current which flows through R2. And in parallel arrangement the potential difference always remains the same. I repeat, in parallel arrangement, the potential difference always remains the same. So there's two key points and two features you can say about series and parallel. So it's extremely important, and we will use these by deriving the equivalent resistance formula. Let us see. So as we know that the current remains the same. So current flowing in R1 and current flowing in R2 will be the same. So I can write that by Ohm's law. I have covered Ohm's law in my previous video. V is equals to IR. Okay. So this is the potential difference across the whole circuit. Okay. So let it be V. Let it be V. So V equals to IR. Potential difference across the whole circuit. Okay. And we can write that for R1 the potential difference would be different, and for R2 also the potential difference will be different, because in series arrangement the current only remains the same, not the potential difference. So the potential difference for R1 and R2 will be different. So I can write it for R1 the potential V1. I will name the potential difference for R1 as V1. V1 is equals to I. Now why I have written I, not I1? Because I have previously told that the current remains the same. So no change in current. We will not take I1 or R2. Only I into R1. So V1 is equals to I R1 simply. Now let us look for R2. For R2, the potential difference will become V2. So V2 will be I. Again I is constant, and R2. V2 is equals to I R2. Now can I write V as V1 plus V2? Because the potential difference, it is the potential difference for the whole circuit, and this is potential difference for V1, potential difference for R2, that is V2. So if we sum that, it will only get V. Simple. So in place of V we can write IR. In place of V1 we can write IR1, and in place of V2 we can write IR2. Now just take I as common. So it becomes I R1 plus R2. I cut, R is equals to R1 plus R2. This is the basic formula to find equivalent resistance when the resistance are connected in a series combination. Simple. What did I do? First I applied Ohm's law and found the potential difference across the whole circuit. The potential difference across the whole circuit will be V equals to IR, that is current flowing in the whole circuit, into resistance of the whole circuit, equivalent resistance of the whole circuit. Now for R1 I told that V1 and V2 will matter because it is a series arrangement, but the current will remain the same. So for R1, V1 is equals to IR1, and for R2, V2 is equals to IR2. Simple. I just put the values in the equation. V is equals to V1 plus V2. Simple. And I derived the formula R equals to R1 plus R2. There can be n number of resistance. You can find up to it can be up to n number of resistance, Rn. So up to n number of resistance you can find by only this formula, R equals to R1 plus R2 plus R3. So let us look quickly at a simple numerical. Let me erase this. So if I say that two resistance, say 2 ohm and 6 ohm, are connected to a source of battery of potential difference V. So what will be the equivalent resistance? So equivalent resistance Re, this is equivalent resistance, will be R1 plus R2. So Re will be 2 plus 6, Re will be simply 8 ohm. In this way we can find the equivalent resistance of in series element. Extremely simple. Now let us move to the parallel element. Hope you understood, and if any doubt you can ask in the comment section. So let us look quickly at parallel element. Now this is a parallel arrangement. There are two resistances R1 and R2 connected in a parallel arrangement to a battery source of potential difference V and a closed switch. So the circuit is complete. A simple arrangement displaying parallel arrangement. Okay. Now we will derive the formula of equivalent resistances in parallel. So again, according to Ohm's law, V is equals to IR. Now can I told you that in parallel arrangement the potential difference remains the same, but the current varies. Okay, so the current varies. So I can write the current across the whole circuit will be I is equals to V by R. From this formula I can write current across the whole circuit will be I is equals to V by R. Simple. This is for across the circuit. Across circuit. Now let us find for R1. So V is equals to I1 R1. The potential difference will be the same, but the current will be different. So here I can write I1 as V by R1. Simple. Now we will find for R2. For R2. So again V is equals to I2 R2. The current will be the different only, but the potential difference will remain the same. So I can again write I2 will be V by R2. Now can I write I is equals to I1 plus I2? Can I write? Because the current across the circuit will be the current in resistance 1 plus current in resistance 2. Simple. Now in place of I can write V by R. In place of I1 I can write V by R1. In place of I2 I can write V by R2. Let us take V common. It results in 1 by R1 plus 1 by R2. V cancel out. So 1 by R is equals to 1 by R1 plus 1 by R2. Understood? Extremely simple derivation of a parallel and a series arrangement. So here we found equivalent resistance. First we applied Ohm's law. Through Ohm's law we got that the current across the whole circuit will be V by R. So this is for across the circuit. For R1 we applied the formula B equals to I1 R1, because I1 and there will be different current in resistance 1 and resistance 2, that will be marked as I1 and R2. And for and we can find I1 as V by R1. For R2 we can find I2 as V by R2. We can write I as I1 plus I2. Just put the values and we cancel out the formula. We get 1 by R is equals to 1 by R1 plus 1 by R2. Let us do a quick numerical on this. Simple numerical. Let us take the resistance to be again 2 ohm and 6 ohm. Now what will be the equivalent resistance? Here in this case the equivalent resistance will be 1 by R1 plus 1 by R2. 1 by RE will be 1 by 2 plus 1 by 6. Now we can take it as 6 plus 1 by 12. 6 plus 2 by 12. As LCM we get as taking LCM we get 12, and we took the LCM and then we simply add them. It results in 8 by 12. So 2 4s are 2 6s are 2 2s are 2 3s are. So 1 by RE is equal to 2 by 3. Now RE will be 3 by 2 ohm, or simply 1.5 ohm. In the case of parallel we simply got 8 ohm, but in the case of series we got 8 ohm, but in the case of parallel we got 1.5 ohm. So the question also comes in this way. Describe the arrangement you will connect to give the minimum equivalent resistance. For the minimum equivalent resistance we always connect the arrangement in parallel, and for the maximum equivalent resistance we connect the arrangement in series. Always remember that. For minimum we connect in parallel, and for maximum we connect in series. So understood? If any doubt you can write in the comment section. That's all. So let us move to our third topic, that is parallel versus series. Which one is better? So before going to the third topic, I have just took a quick numerical to just build a concept on the resistance combination extremely strong. So this is a simple numerical. You have to find the equivalent resistance in this numerical. Simple. So as we can see that two resistances connected in parallel, we can write that 1 by R is 1 by 2 plus 1 by 2. So 1 by RE will be 2 by 2, that is 1. So RE is equals to 1 ohm. Now we got the value of this resistance as 1 ohm. So the equivalent resistance here will be, you can imagine as 1 ohm, and you can just erase this. So here we got in place of this as 1 ohm. Okay. Now we can see now this arrangement is in series. Simple. Now these three resistances are connected in series. So we can find RS. S denotes series. So 5 plus 1 plus 2. So RS becomes nothing but 8 ohm. Simple. So this numerical cleared our concept on resistance combinations. Now let us move to our third topic. So here I have drawn the parallel versus series and written 4 points for each one of them. So basically, first let me tell you an important thing, that in domestic circuit, in our household and in our houses also, the circuit which is used, the arrangement which is used for collecting lights, bulb, fans is nothing but parallel, not series. It is parallel. So the appliances are connected in our home in a parallel arrangement. So what are benefits of parallel arrangement? Why we have adopted a parallel arrangement in other than a series arrangement? So what is the reason behind why we have chosen parallel arrangement? So this will tell you all the reasons why we have chosen a parallel arrangement. So first and foremost, the potential difference or V remains the same. So as we discussed earlier that in parallel arrangement the potential difference remains the same, and in series arrangement the current remains the same. Simple. But here it has a disadvantage also. If the current remains the same, So the low current needing appliances, like if there is a toaster and there is a small 100-watt bulb, so the 100-watt bulb needs a extremely low amount of current as compared to toaster. So it will heat over it, it will hover it, and it will also disrupt the appliances. The appliance will be so the appliance will stop working and it will disrupt. Now, so as we discussed that current remains the same, it has a disadvantage. But if the potential reference remains the same, that it doesn't have any disadvantage, because every appliance needs at least 220 volts in our I am talking about domestic appliances. It needs 220 volts to work, and which is fulfilling by potential difference. So every appliance gets the same potential difference, but the current varies. So it has an advantage over series. Now, if we talk about appliance, so in a parallel arrangement, every appliance has an individual switch. But if we talk of a series arrangement, there is a single switch for the working of all the appliances. So if you just switch on, all your television, your fan, your tubelight will work at the same time only. Because there is only a one switch for the working of the all the appliances. So here it is a disadvantage. But in the parallel arrangement, there is a single switch for all the separate switch for all the appliances. For fan there is a separate switch, for tubelight there is a separate switch. So it is an advantage. And the most important point of parallel arrangement, that if one appliance stop working due to some technical snags or technical reasons, one appliance stops working, then it doesn't affect the other appliances. It doesn't affect the whole circuit. The whole circuit works. Every other appliance other than that one which stopped working, every other appliance will work, but the circuit will do not be broken. And if we talk about series, and if one appliance stops working, either say the tubelight stops working, so the whole circuit will not work. Your fan, your television will not work if your tubelight is not working. So the whole circuit will stop working if any one appliance is just broken, or have some technical reasons not working. Now, in parallel, as we discussed earlier, that the overall resistance is extremely minimum, or you can say extremely small or minimum. The overall resistance is very small, whereas in series arrangement the overall resistance is maximum. Okay, so this only lowers the current, because resistance is inversely proportional to current. So if the resistance will be high, the current will eventually be slow, and if the resistance will be extremely small, then the current will eventually be high. So in that case, resistance is maximum. We are in this is a disadvantage. So the current will be very extremely small as compared to parallel. So these are some of the reasons whereas why we use parallel in domestic circuits, and also why parallel arrangement is better than series arrangement. Both the question have the common answer, these 4 points. Thank you guys for watching my video, and please do like, share and subscribe my channel Abbot Academy, and stay tuned for further videos. Thank you guys.